Hey everyone, welcome to Code Harmony, and today we are going to cover binary search algorithm along with a couple of standard problems on it. So far we have been looking into the arrays, and the main property of the array is that any element can be accessed in a constant time. So let's say this is an integer array and I tell you that I have to access the second index. You can directly tell me the second index in the O1 time. So the access time is order of 1. But when I tell you that you have to search an element in the array, all the elements are randomly arranged and you have to iterate over the array from starting to end to find the desired element. So in that case, the search complexity goes order of n. But if I tell you that I am giving you an array where the arrangement is something like this, all the elements are in the increasing order. Here, you can put the logic like you search a word in a dictionary. You let's say you have to search a word mango in a dictionary. So you just open the dictionary and you decide whether you have to search on the left part of the dictionary and the right part of the dictionary, or you have that element. It means that in every step you are discarding half of the space. Every step you are discarding n by 2 elements. Okay, so and these are the main conditions to be able to use binary search algorithm, that the data structure should be sorted and the access to every element is a constant. And we know about the array accessing any element is a constant operation. And if I make all the elements sorted, so it will fulfill both the condition for binary search algorithm and we can use it. Now, as the elements are sorted and it's an array, if I tell you to find an element with value 5, you can do that for me. How you're going to do this? We know the indices are from 0, 1, 2, 3, 4. Let's say we are checking the middle element for now. Our range is going from index 0 to 4. And what is the middle element? Let's say it is 2. So we will check the value of 2. Here the value of 2 is 4. It means that the desired value, which is 5 is greater than 4. It means 5 will definitely be on the right side. So what we can do here is we can discard this whole space. And now we have to search only in this section. So we were given n element, and after one step it has become n by 2. After one step it has become n by 2, and at some moment it will become one single element. So the time complexity is log of n, because at every step we are making the search space half. So in this way it is better than accessing an element in a random random array. So here the search time was order of n. Now the search time has become order of log of n. Now try to have a look on the detailed view of what I did in this. First of all, I should have a search space. Let me call those boundaries as a left and right. Now we know our boundaries, and now we have to see at every step we'll calculate some kind of key. Here let's say we call it middle value of our current range. How we can do that? Left plus right divide by 2. There are three possibilities: whether the middle value is equal to our target, or whether the middle value is less than our target, or greater than our target. If it is less than our target, it means the target is definitely on the right side. If the middle value is greater than our target, if the target is definitely on the right side. But if it is a target, we can directly return it. So what is our current step? Our middle element is going to be our key for this step, and that we can find by dividing it by 2. So now we have three possibilities. What are those three possibilities? If the number in the middle is equal to the target, if it is greater than the target, if it is not equal, not greater, it is definitely the less than the target. If it is equal to the target, we have found that value in our array. So we can directly return the index. And what is the index? Index is the mid element. If it is greater than the target, It means that the current value is greater than target. If let's say in this case I have chosen 2 as a target value and the middle value is 4, so the search space in the next step is going to be the left part. So nums mid is greater than target. In that case, my search space was initially from left to right. Now the left will remain same and I will shift the right to this side. My mid -1. What if the mid element is less than the target? It means I have to shift on the right side. It means the right range will remain same and the mid left pointer will be equal to mid plus 1. Left is equal to mid plus 1. So at every step we are reducing our range. Sometimes we are reducing right, sometimes we are reducing left. So we'll keep on doing this step while left does not surpass right. So while left is less than equal to right, we'll keep on doing this. And whenever we have encountered our target, I will return mid. If let's say we have come out of this loop, out of this while loop, it means the element is not present in the array. In that case, currently I am returning -1. So this is going to be our algorithm for the binary search. Here the first problem is binary search. It is a standard binary search problem that we are given a nums array, which is a sorted integer array, and we are also given a target, and we have to see whether the target exists in the array or not. If it does not exist, just return -1, and you must write an algorithm in order of log and runtime complexity. As they have given a sorted array, so while searching any element in the array, we'll just do the binary search algorithm. So that I have written here. We will do the standard approach. Firstly, we will define the range. Initial range is going from 0 till last index. And while the left is less than equal to right, it means the left pointer is not surpassing the right pointer. It means we have a valid range. When the left and right are equal, it means we have a single element in our range. Firstly, we calculate the mid element, which is our key for this step, and we will see whether the element at the mid is equal to target or not. If it is equal to target, it means we have found the element we can directly return from this function. Otherwise, we have two possibilities, whether we have to discard the left part or the right part. If the element at the middle is greater than the target, it means we have to discard the right section along with mid. So we are making right pointer shifting to mid -1. This is the mid element. And if mid element is greater than the target, it means we have to discard this one and this section. So this whole part we are going to discarding. Otherwise, in the opposite case, when the array of mid is less than target, it means that I need a bigger value of target. I have to shift to the right side. So I will be shifting left to mid plus 1. So this is what is asked in this problem binary search. And they are also saying that if the array does not if the element does not exist, return the -1. After this loop, if the function is not returned from here, we'll just return -1 from here. And this is the whole solution for this problem. Now let's have a look on the second problem, which is search insert position. Given a sorted array of integer and a target value, return the index of the target value if it is found. If it is not found, return the index where we have to insert that value to make it sorted. It means, let's say this is the array is sorted, so we can use binary search here. Target value is 3. 3 is not present in this array. It means that we have to return an insert position, the position where we have to insert 3 in this array, so it will remain sorted. If I have a look on the indices 0, 1, 2, 3, 4, at what index we should insert 3? 3 should be inserted here at second index, and we are going to shift all the array on the right side. So in this case, our logic will remain the same, that if the target value is found, we will return the target. But when we are coming out of the loop here, when we are coming out of the loop, we are sure that the element is not present in the array, and now we have to see where we have to insert the array. So first of all, initially the range was something like this, left and right, and the mid element was this one. Mid element is greater than the target. It means we have to reduce our search space to the left part. So the right will be shifted to here. Okay. And now we will compare the mid element. Mid element is 0 and 0 is less than the target. So we will shift the left part. Left part will shift it to this one. This is also a valid range. Left is less than equal to right as per this condition. Now, what is the mid value? Mid value is also this one. Mid value is less than the target. It means we have to shift on the right side. And when we are shifting on the right side, we will use this condition, left equal to mid plus 1. Left is equal to mid plus 1, which is this. Left will be shifted to here. And now the condition is breaking and we are coming out of the loop. And at this moment, I have realized that at the left position, I have to insert the target value. So when we are returning from this function after the loop, I can directly return left. It means if you have to insert the target in the array, you can insert it in the left pointer. Okay, I hope it is clear to you that if the element is found, that is fine. Otherwise, just insert that element in the left position. But there is one miscellaneous thing over it. How do we distinguish between that whether the element is found or it is the index of the insertion position? Because let's say if the array given to us is this 0, 2, 3, 5, 9. What is the answer in this array? It is also going to be 2. So the answer from this is also 2. Answer from this is also 2. And how do we distinguish that whether it is a position of the target or it is the position of the index where we have to insert the target? So to make it, what we can do is, instead of returning left, we can return -1 into left. We will get to know that if it is a negative value, it means it is an insertion position. If it is a positive value, it means it is the position of the target. But one special case is also there. Indices values are from 0 to n, and all the values from 1 to n can be the negative value, but 0 cannot be negative value. If it means, in this case, I will just insert +1. -1 into left +1. If I return this value, then we can distinguish between whether it is an insertion position or it is a value of that index. And this is the logic which is used in inbuilt functions of binary search. Whenever, let's say, you are implementing a binary search, writing a binary search function, utility function from Java collection framework. So if you encounter a negative value, that is returned in this form. If it is a positive value, it means it is an index. Positive or 0 value if it is an index of the target. Okay, so this problem is also clear to you. I hope you will be able to code this out on the lead code. And let's say, what is our third problem? Our third problem is the first position and the last position of any element in a sorted array. Okay, so let's create a sample case for it. Let's say we are calling it 0, 2, 2, 3, 5, 9. And in this problem, if I give you target equal to 2. So what is the first position? First position of the target is 1 and the last position of the target is 2. How do we do this? In this problem, whenever we are encountering our target value, we are just returning from it. Okay, but in this case, let's say we have encountered 2. Now we are not going to return from the function, from the loop. what we are going to do is we will capture that value. Okay, that can be the candidate of our answer. It means that there are two possibilities. That value can be the first value or any middle value. Okay, so what we can do is whenever you are encountering a target, just capture it and keep on exploring further on the left side. If you are required the first element, if you are required the last element, keep searching on the right side. Now we have to find the first element and the last position. First position and the last position in a sorted array. And this is our array. And if I have to search for the target 2, the first position is 1, last position is 2. And this is our standard binary search algorithm. If we have encountered the target, just return the value. Otherwise, I'm just keeping it -1, not considering the insertion position. So in this case, I'm just directly returning the target, pre-assuming that it is existing only one time. But let's say if it is coming more than one time and we have to find the first occurrence. How do we capture the first occurrence? Whenever you are encountering a target, if you capture that target and keep on exploring further for the first element. Let's say I'm getting another variable first to store the first value. So the first is going to be equal to target. It means that target can be the first element or not the first element. So if it is first element, it's already captured. Otherwise, we'll keep on further exploring the first element. So now we are in the need of first element. It means that we have to go to the left. If we have to go to the left, so I will shift the right pointer to mid -1. Instead of returning, just capture the element and keep exploring further. You will get the first element. And let's say, what if we have to find the last element? In that case, take another variable last for it. So instead of first, I will capture it in the last. Last is equal to target. And as we have to capture the last element, so I will shift on the right side of the mid. So left will become equal to mid +1. Simple. So we are not just returning, we're capturing and keep exploring further. If you want the first element, explore on the left side. If you want the last element, explore on the right side. Okay, I hope this is clear to you. I will add the link of my repository, which is containing the solution of all of these problems. And along with that, I would suggest you to try it out by your own on the lead code. And there is one thing, that in all the question I have used only one approach, like whether the target is found, whether we have to go to the left side or the right side. I'm not adding any special condition. So whenever I encounter any question which is involving binary search algorithm, I use this way. Okay, I hope you understood the approach. Thank you. Bye bye.